One night, a star was visible in the sky. The next time astronomers looked, it was gone. No explosion, no gradual fading, no warning. That alone sounds impossible. Stars don't behave like this. They don't simply vanish between observations. Especially not massive stars, objects so large they dominate their region of space. Yet this one did. The star lived in a nearby galaxy known as NGC 6946, often called the Fireworks Galaxy. Astronomers watch this galaxy closely because it produces supernovae more frequently than most others. This star was well known, carefully catalogued, monitored for years. Then, sometime after 2009, it stopped appearing. At first, no alarms were raised. In astronomy, missing data happens. Dust, interference, equipment limits. There are many reasons a star might temporarily disappear. But this wasn't temporary. When scientists checked older images, something unsettling became clear. The star hadn't dimmed slowly. It hadn't flickered. It hadn't shifted position. It was simply gone. And if that star had exploded, as massive stars normally do, the explosion would have been impossible to miss. Supernovae are among the brightest events in the universe. But no one saw one. That absence would soon raise a much bigger question. What if the star didn't explode at all? What if it collapsed so completely that it left almost nothing behind? And if that could happen once, how often was it happening without anyone noticing? Astronomers understand stellar death remarkably well. Small stars, like our sun, live long and fade gently. Massive stars burn fast and die violently. When their fuel runs out, gravity collapses the core, triggering a supernova explosion that can briefly outshine an entire galaxy. That's the rule. And rules matter in science until something breaks them. This vanished star was a red supergiant, exactly the type expected to explode. It had the right mass, the right age, the right location. Everything pointed toward a dramatic ending. But nothing happened. No burst of light, no expanding debris, no lingering radiation. That left scientists with only uncomfortable explanations. Could dust be hiding it? Infrared telescopes can see through dust. When astronomers checked, they didn't find a living star behind a dusty veil. Only a faint glow that slowly faded. Could the star have moved? Stars don't move like that. Not on human timescales. And nearby stars remained perfectly visible. One by one, the usual explanations failed. And that forced scientists to consider a possibility that had long existed only in theory. Some stars may die without exploding. For years, computer models had hinted at something strange. Under certain conditions, a massive star might fail to produce a supernova. Instead of rebounding outward, the collapsing core could continue inward without resistance. Gravity would win instantly. A black hole would form almost immediately. In that scenario, the star's outer layers wouldn't be blasted into space. They would fall inward, swallowed by the newborn black hole. From the outside, the star would simply disappear. This process is often called a failed supernova, not because something goes wrong, but because the explosion never happens. Until recently, this idea remained unconfirmed. No one had ever clearly seen it happen. Now, astronomers might have, but extraordinary claims require careful verification. So they kept watching. Astronomers returned to the same patch of sky again and again. Years passed. The star did not return. No expanding gas cloud appeared. No delayed explosion occurred. No hidden source reignited. Instead, the faint infrared glow continued to cool and fade, exactly as predicted if leftover material was slowly losing heat. This long-term silence mattered. If a supernova had been missed, evidence would eventually appear. But nothing did. The conclusion became harder to avoid. The star wasn't hiding. It wasn't delayed. It was gone. And that realization opened a much larger question. If one massive star could collapse quietly, how many others already had? For years, astronomers had noticed something subtle. There were fewer supernovae than expected. When scientists compared how many massive stars existed in nearby galaxies with how many supernovae were observed, the numbers didn't quite match. The gap was small but persistent. Now, this disappearing star offered a possible explanation. Some stars weren't exploding. They were collapsing silently. That meant black holes could be forming far more often than previously believed, without producing any obvious signal. A universe quietly manufacturing black holes. Black holes emit no light of their own. Most are discovered only when they interact with other objects, pulling material from nearby stars or merging with other black holes. But a black hole formed in isolation could remain invisible forever, a silent remnant of a vanished star. That makes events like this incredibly difficult to detect. You don't see what forms. You notice what's missing. This discovery changed astronomy's approach. Scientists are now tracking massive stars directly, cataloging them, revisiting them year after year. They aren't waiting for explosions. They're waiting for disappearances. New telescopes make this possible, allowing astronomers to measure absence itself. Silence has become a signal. Supernovae shape galaxies by spreading heavy elements. Quiet collapses don't. If failed supernovae are common, galaxies may evolve differently than expected. Fewer heavy elements. Different star formation histories. Even life's building blocks depend on how stars die. This single disappearance reshaped more than one theory. The star didn't truly vanish. It likely became something denser, darker, more extreme, a black hole. Still there, still shaping its region of space, just unseen. And that may be the most humbling lesson of all. The universe doesn't always announce its biggest moments. Sometimes it simply continues, quietly. If you enjoy exploring real space mysteries grounded in careful science, you may enjoy more stories like this. Subscribing helps support documentaries that listen as much as they look. Because out there, stars are still disappearing. And each one reminds us of something profound. The universe doesn't always speak loudly. Sometimes, it tells its biggest secrets in silence. If some of the universe's most important events leave almost no trace, how many cosmic stories are unfolding without us ever noticing?